Good morning, boys and girls. In a previous video, we talked about how to use partial products to divide a number and have remainder. In today's video, I'm going to teach you how to take that, what's left over after you've evenly divided something, and how to divide that further. Okay, so we're going to be dealing with fractions and with decimals today. All right, so let's get started. So in a previous video, we were talking about if we had 96 marshmallows and we were to divvy it up for 5 kids, and we set up the problem so that we put 96 in our house. We put our number we wanted to divide, our groups that we wanted to divide into. We drew a long wall, and then we started making some guesses. I'm going to go ahead and speed up this process a little bit. I know 20 is probably a little bit too big, because I know that 20 marshmallows per 5 kids would be 100, and 100 is bigger than the number of marshmallows that we have. So I'm going to go a little bit smaller, and I'm going to say 19. So I'll go ahead and just test multiply this to make sure that it's in the ballpark. 5 times 9 is 45. 5 times 1 times 10 is 50. 60, 70, 80, 90, 95. Okay, so I was pretty darn close. When I gave each kid 19 marshmallows for 5 kids, I was able to get rid of 95 marshmallows from my bag. That means that I have only 1 marshmallow left over. Okay, so 5 hungry kids, they all got 19 marshmallows per kid, and I had 1 left over. Well, what can I do with that 1 marshmallow? Let's draw a picture of it to kind of imagine. Here's 1 marshmallow. And you might be thinking to yourself, okay, if I have 5 kids, well, if I wanted to be very, very fair and maybe not give this to the teacher for the teacher to eat, and I wanted to be really, really fair and give a part of this to each of my 5 kids, well, I could just divide it into pieces like this. 1 slice for Billy, 1 slice for Susie, 1 slice for James, 1 slice for Jonathan, and 1 slice for Nahom. Okay, so there's all of our slices. I would be giving each of the 5 kids, 1 of those slices. Okay, so let's ask ourselves, if each kid gets 1 of those slices, how much is it? Well, look how many slices we were able to make. We made 1, 2, 3, 4, 5 slices. And we're giving each kid 1 slice. Okay? So as a fraction, we gave each kid 19 whole marshmallows plus 1/5 of a marshmallow. Or let me write this a little bit clearer. 19 and 1/5. Okay, so as a fraction, this is how we would represent with no remainders. We would be giving the fractions. We had 5 kids that we wanted to divide into. We had 1 left to divvy. Our answer would be 9 and 1/5. Okay, now sometimes you might have to deal with decimals. Okay, if this is confusing to you, it's totally fine. You can keep it as a fraction, but for some kids, I'm going to go ahead and explain how to go into decimal land, how to make this into decimals. So if you feel like this is confusing to you already, maybe you want to end the video here. All right, so we have 1 marshmallow that's left over, and we want to divide that into 5. One strategy that mathematicians use is they can imagine that there's a 0 here. Okay, there's actually a 0 after every whole number, and we can continue to add zeros forever and ever. In fact, let me go ahead. I'm going to keep my 19. I'll draw it over here. 19 whole marshmallows. I'm just going to extend my wall a little bit so that I have space to draw some zeros. In decimals, it's fine to add zeros after our whole number because we're not changing our whole number. We're not adding any more tenths. We're not adding any more hundredths. We're not adding any more thousands. It's fine to add those. Now what I'm going to do is I'm going to bring down one of my zeros down here, so that now I can kind of imagine that instead of dealing with one marshmallow left over, this kind of looks like 10. Okay? So now I can kind of ask myself, if I'm splitting 10 into 5 groups, how many would I be able to give? Now, remember, we're not talking about a real 10 here. This is kind of like a trick that mathematicians use. Remember, we don't have 10 left over. We just have one marshmallow left over. We're still splitting one marshmallow for 5 kids. We're still doing that. But we want to know in terms of our decimal or part of a whole, how many each kid would have. Well, let's start to make some guesses here. If we give each kid, let's say we give each kid a 0.3 or 3/10 of a marshmallow. Let's multiply that times 5 and see how much each kid would get. Again, the zero strategy will work for this as well. 5 times 3 is 15. All right, but look, we were dealing with a decimal. In other words, we were 1 away from what we were multiplying here. So we just move our decimal over here. We got 1.5. Excuse me. That's a little bit too big. Each kid would not be able to have a third of the marshmallow because that's too much. Why don't we try 0.2 per kid? Let's divvy that out. 5 times 0.2, 5 times 2 is 10. Now notice we were 1 away from the decimal point that we moved it over, so we need to do that in our answer. Aha! If we divvy 0.2 for each kid, we will be able to get rid of our whole marshmallow. All right, so that's what we were able to give to each of our 5 kids, 0.2. All right, if we do our same partial products, we add the 19 marshmallows, plus we add our 0.2, and let me actually line this up the way that it should be. Excuse me. 19 plus 0.2 is equal to 19.2, or 19 marshmallows and 2/10 of a marshmallow. That would be our answer using decimals.